First, I'd like to thank everyone for joining in on our webinar this afternoon with Parallel M. During the past few years, AI World and AI Trends have hosted dozens of webinars with world-class experts covering the business and technology of AI in the enterprise. These are all available to our readers complimentary, so be sure to check it out on AI Trends. AI World and AI Trends were created to help enterprises get unbiased insight and analysis on the state of the practice of enterprise AI. We were proud to announce last December that AI World has become the largest independent AI event in the U.S. AI World will be returning to Boston this coming December from the 3rd to the 5th at the Boston Seaport Hotel and World Trade Center. We've planned for a broad expansion of content and industry coverage, and we look forward to updating you in the coming weeks, including details on our conference program and many special events, so stay tuned. Despite the huge investments and very high expectations for machine learning, only a small percentage of machine learning initiatives actually make it into production. In order for companies to take advantage of all that AI and machine learning have to offer and generate a positive return on investment, they must understand the challenges that come with the critical phase of running machine learning in production, as well as what it will take them to successfully deploy, manage, and scale those technologies across their enterprise. So today I'm very pleased to welcome Sivan Metzger, who will be presenting today's webinar, Why Businesses Aren't Seeing ROI from AI. Sivan Metzger is the CEO of Parallel M and brings close to 20 years of experience in enterprise software and leverages his background to help companies successfully take machine learning into production with Parallel M. Prior to Parallel M, he founded and served as GM of two business units, Kenshu Social and Kenshu Local at Kenshu Inc., an enterprise software company for leading online marketers. And prior to Kenshu, Sivan spent close to a decade at Mercury Interactive, prior to his acquisition by HP in 2006, where he led numerous business and product leadership roles across the company. So, welcome, Sivan.
Hey, good morning and good afternoon. Thank you very much, Elliot, Elizabeth. Thanks for having us on the AI Trends webinar. Good morning and afternoon, everybody. Thank you for joining us today. My name is Sivan, as Elliot said, and I'm the CEO of Parallel M. What we do is machine learning operationalization. It's our favorite 18-letter word. And we're going to talk today about why businesses are not seeing yet, I would add, AI ROI. Let's jump in. The way I'm going to walk through this today is actually I'm going to be telling you a story, and the name of the story is the AI impediment. If you kind of think about this word, it really connects to the title of the slide, and I think at least the way we're seeing the industry, it's very relevant for many places. Let's jump in. But the last thing I'll do before we do is actually a spoiler. So let me start with a spoiler. So this is a very scary slide. I like to start with it because it kind of gives the lay of the land. Don't bother reading all the small letters here, but the concept is that the majority of our industry is in the academics phase, which is the left side of the phase. The academic phase of machine learning actually involves a lot of very experienced people, big data experts, data scientists, data engineers, citizen data scientists, etc. It has a whole set of technologies that is super relevant for the phase. We kind of label it academics, but most people refer to it as the build stage of machine learning. On a personal note, my previous company, I was leading a couple of businesses, all of which utilize machine learning, but I kept personally as a business leader knocking on the door of the head of machine learning. We called it research then, and say, hey, why are all your promises, your machine learning promises, why aren't they running yet? Why am I not seeing this? And he would have a whole list of very good reasons. And frankly, I didn't really understand it. I didn't understand why I cannot see all the value of their precious work in production. Part of that frustration is leading us to what we're doing today. But the notion is that to get economics out of these academics, which is the right side of this equation, you need a completely different set of people to be in full alignment with the first set of people. So IT folks, operations folks, security, legal teams, governance teams, business analysts, architects, it's a complete different set of people that have a complete different background and a way of doing things on the day-to-day, that unless you get that collaboration between those two groups, as well as their technologies, so what happens with live production data as opposed to canned lab data, analytics engines that are running actually in production as opposed to the lab, what are the network constraints, security constraints, you name them. And what are the actual eventual ML applications that need to run into production to deliver a service, as opposed to algorithms and actual models, trained or untrained. Crossing this gap between these two islands, if you will, or planets, is the only way you can eventually get to the far right side of the slide here, which is the actual results of actually getting some tangible ROI from AI, actually reaching your business goals, and having the business side, or my previous self in my previous company, understand that they're finally getting actual value from what's being created, which takes so much work to create on the left-hand side. To actually make it to the finish line requires that collaboration with the right-hand side. So the spoiler here is that there is a way to get there, and we're going to go back to the story, the AI impediment story. I think we all know that enterprise AI initiatives, at the end of the day, I would say 99% of the overall, let's call it AI-aware industry globally, 98 or 99% are largely failing to deliver on the actual promise of AI. So I think the promise and the expectation is like somewhere around the ceiling, and the reality from what's actually running and what's actually delivering value for either internal customers, external customers, or whichever way the business or government agency is structured, is actually somewhere just an inch above the floor in most cases. And it's not because there are no investments, and it's not because there's no, a lot of really, really smart people working towards generating these AI services that should be coming out. But so few of them, despite all that, actually reach the deployment phase, which is very, very frustrating. What we're seeing is that the industry is really lacking a scalable best practice of driving deployment and management of machine learning applications in production. And we're labeling that MLOps. We'll talk about that in a minute. Which is the analogous equivalent of software to DevOps, machine learning services to MLOps. It took years to get to a point where it's very clear to everyone and anyone that to drive software in production, you need a DevOps team that will be, the handoff between the software engineers and the DevOps engineers has become, over the last couple of years, not that many, by the way, very, very clear, very straightforward, and that interaction between them is very mature at this point. We believe that an MLOps maturity layer, kind of, if you can call it maybe a new class of DevOps, is emerging as we speak, and is fundamentally becoming that bridge between the academics to economics, and the way to ROI from machine learning. So we talked about the high level problem here, but I think in everyone's mind is okay, so we're building all these models, and people in the world know how to deploy stuff in production. So what are those unique challenges of deploying and managing machine learning in production? What haven't we thought about? Well, there are many, many facets to this. The most fundamental ones are roughly summarized in this three, but there's obviously a whole list of additional ones that we should talk about in a second. But at the end of the day, on the left-hand side is what we call a data science sandbox, but it's where the data scientists, data engineers work and prepare, develop, test, release, which is obviously an ongoing cycle. And at some point, they need to press the button, or somehow, figuratively speaking, throw it over the wall somewhere. More often than not, that somewhere doesn't really exist, or doesn't have that baseball mitt to be able to capture or catch what's being thrown at their direction. And number one here is talking about the fact that there is such diverse focus and expertise between data science and data teams and the operations teams. They have not worked together in the past. They both come really from different worlds with different sets of experience. And what we're seeing in many, many companies we go to is that they haven't even really, in most cases, sat around the table and devoted a serious amount of time to actually nail out even the whole set of the issues, let alone the solutions to those. And we'll talk about that in the next couple of slides. Second is hey, it's really risky to deploy non-deterministic machine learning applications and bet your business on it. The machine learning models are super sensitive to data, super sensitive to all kinds of other things that are happening in the environment. And at the end of the day, the reason we're all building machine learning applications is so that they would automate some downstream business process, such as, if an engine is going to be faulty, then shut it off or add lubrication or something. If a deal or a mortgage deal should not be going through, then shut it and do not let it go through. If some kind of fraud is taking place, have the ability to automate somehow stopping the continuous contamination of that fraud across the business. So there's so many things that at the end of the day, you want your machine learning services to automate downstream. If your machine learning is not doing what it's supposed to do, it will continue to predict something, and that automated business process will continue to be executed, but it may be based on something that's completely irrelevant, and you have to have a way to gauge that and manage that. Otherwise, you'd be obviously increasing the risk to your business or your agency. So that's number two. And the third is people are still asking us whether, hey, I have a DevOps solution or an operation solution. People mentioned Jenkins, for example. Why can't we just deploy it with Jenkins? Well, having been in this world from the year 2000, having actually been participating in building the very first APM solutions back in 2000 in previous companies, these solutions are really not built for anywhere near what the implications and the complexities of those that ML applications are really introducing to our world, for better or for worse. And therefore, we believe the new class of solutions has to be created in order to supplement the gap that we talked about of not having an industry best practice of MLOps. Moving along here, so what does it take to do MLOps or to have an MLOps strategy to really automate that production ML lifecycle? What does it mean to automate the production ML lifecycle? We all know life cycles. We all know that there's machine learning. Most of us have been focusing on making sure we manage to build the right machine learning models and get what we need to do that. But what happens actually the moment after? So in this slide we're showing now, this is the accumulation of a lot of work that we've been doing with literally hundreds of customers, mapping out what really are the core elements, if you will, of what needs to be taken into consideration when you build an MLOps strategy. And think of the entry point from the left being that there are a very clean and ready and QA'd set of machine learning models that are ready for deployment in production. This could be kind of the assumption as you head into and the creation of an MLOps strategy. The very first thing you need to make sure you have is the equivalent of a CI/CD mechanism in the world of machine learning, which we believe should be the notion of automated A/B testing and canary testing options, depending on the business. Think of it as a champion challenger gateway that actually happens and takes place upon actual production data, as opposed to testing out and concatenating multiple models in the lab against multiple sets of data that we have in the past. Production reality, typically the characteristics are very different, and having the ability to do actual live A/B testing against production data is essentially the equivalent of CI/CD from a machine learning model standpoint. Next, any ML application is radically different than any other software application by the pure notion that at the very least they have two sets of pipelines, training pipelines and inference pipelines. More often, it's far more complex, and the characteristics and relationships and dependencies between those pipelines is much more complex as well. And the notion of we call the management of those dependencies ML orchestration. The notion of being able to manage those dependencies live in production in an automated manner is super critical. So having an automated ML orchestration mechanism is important. Next is kind of where it all comes together, right? ML health. Is the ML that we're driving right now producing healthy outcomes that are relevant and right for the business? So think of it as providing a set of qualitative indicators to the quality of the output of your machine learning in kind of a dashboard format. I'll show an example in a few minutes. Understanding as close as real time as possible whether or not my machine learning services, let's just, in a financial world, it could be fraud, it could be mortgage service, credit card approval service, ATM confidence service, you name it, right? You have a multiple layer of services, website experience. All those are each, a service which machine learning is supporting. Are all of my services, or is every one of my services actually healthy right now as we look at this? And this is something to make sure that is being looked on and taking corrective action as soon as something happens. Corrective action could be, stopping a service or correcting a service or rolling back a service as soon as the quality of the output is deemed insufficient. That's ML health. Business impact is, think of, if ML health is quasi real time, business impact is the over time representation of that quality. So how well have we been doing since the beginning of the quarter? Have we improved the quality of our ML service, or is it going down? Or since the last retraining of a set of models for a specific service? It's both a way, obviously, to improve the delivery of these services, but also a way, I think it's almost as important, to be able to show the business counterparts that the actual investment that's going in here is actually yielding a positive benefit for the business, and not negative or flat or other. The way that having ability to understand that over time is critical. This also is a place to actually mesh and merge in business KPIs if those are available, to be able to come back and represent the actual business impact that the machine learning models have had on the business. Last but not least here is production model governance. Think of in production, the ability to understand complete lineage historically of which model versions supported which ML services 2.5 weeks ago at 3 a.m., for example. Or if anyone had touched the system, was it within process, outside of process, within permissions, outside of permissions, was it automated or manual? So the notion of which models ran and who had or what had fingerprints on what actually took place in production is becoming increasingly important, both from anywhere from GDPR through explainability, through actual governance and compliance, all the way to process improvement and deep diagnostics. Production model governance plays a key role in all those areas. Now, a lot of words said here, but all that framed into some kind of collaboration framework and architecture, having the ability to have different roles access different representations of the goodness that I described right now is key. Meaning an MLOps person should be of kind of a 24/7 kind of nature, having the ability to look and take basic corrective actions for the healthy running of these machine learning services. That's one. Another should be people from the data team, various roles, being able to look as a tier 2, drilling down into specific issues and having the ability to peer into what actually is happening in production based on their role. And of course, the business analysts or business representatives of product to be able to understand how well the service is actually acting and behaving, and if there needs to be anything taken care of. That would be the role-based architecture accessing the functionalities that we're talking about here right now. I want to talk a little bit about how this actually works in real life. So kind of rolling this story forward, bringing the way this typically happens in the places where we are fortunate enough to be part of the scaling of their machine learning services. The way it starts is usually for the first time, we manage to bring the different constituencies in the company together. So the IT and operation representatives, obviously the data science folks and data engineers, bringing in the chief architect, the person that has to look at how this thing is going to work together 2, 3, 5, 12 months from now. The business analyst, which represents the business stakeholders and the governance folks and others depending on the team and the organization, putting all those together in a room and sometimes for a day and a half, and actually hashing all the issues out, because you'd be amazed that all these people have actually completely different issues and concerns as they approach deploying and scaling machine learning services into production, and putting all those together around a technology solution that can help each one of them be more confident about the accountability they can actually own for delivering the service is a key part of pulling together an MLOps strategy. By the way, I didn't say this before, but I'm assuming many of you or many of your customers maybe have 1, 2, or even 5 services in production. But what we're really seeing super consistently is that everywhere that you manage to deploy 2 or 3 services in production, that is typically the point that the business is actually finally, after 2 or 3 years of investing and waiting and anticipating for the delivery of machine learning services and their advantages, once you manage to pull together the first 2 services, that's when and you come and show them, that's when they wake up and say, hey, if you got the 2, we want to be at 50 or 100 services by the end of this year, please. And everyone, typically, that's kind of an oh no moment, looking around, shit, we got to 2, how are we going to get to 100? Definitely not in the same way. And that's typically the point. People are looking to pull together a strategy as opposed to using toothpaste, bubblegum, and Excel to put 1 or 2 services in production. As a matter of fact, this morning we had a call with a customer. How did they say it? They had a good way of wording it. Since they were doing everything manually, it's all based on Excel spreadsheets. When to train a model, when to check that model, and they have dozens of customers, each of them with growing number of services. That's actually hard coding your team to plug things into their calendar. Monday 9 a.m. retrain model A, Monday 10 p.m. Retrain model B, and across multiple applications. That's completely unmanageable. So that's why, just one example of why things need to be really automated here. I wanted to show you just an example of what to kind of put some color to it, what an MLOps dashboard should look like. MCenter is the name of our product, but I just want you to understand what an MLOps solution needs to be looked at. So for the MLOps professional, the dashboard you see in front of you right now, a representation of all those services that are actually running in production. There's 4 of them at the top bracket of the screen here. One of them actually is experiencing an ML health issue, an alert log list of a log list of all the alerts and events that are happening for each one of these services, and of course the ability to drill down on those. The bottom part, we call it sandbox in production. Those are the models that are the behaving right now as champion challenger. So for the first one that's running there is actually a challenger that's running against one of the top models. As soon as that one overcomes the top model, that becomes the production model instead of sandbox in production. So you kind of have two sets of models in this kind of world that runs against the production data and system to make sure that you're getting better results. So this is the way an MLOps dashboard would look like. Next here is the representation of what the data science view of the same kind of event, if you will, look like. So it's a much deeper type of view that allows for the data scientists to look either in the present or in the future. Say they come Monday morning and they don't need to necessarily be called in on Sunday night. They would log in and check in from a time horizon what actually happened, Saturday night when some issue took place, and they have their own much more deeper and finer type of representations of the performance of the machine learning models actually in production with data histograms, feature heat maps of volatility of feature performance, etc., that help them dive deeper and find the actual resolution of a problem. This is opposed to the MLOps person that doesn't necessarily need to understand all the deep characteristics of what's actually happening within every single model, but actually can take actions like rolling back or pausing a service or restarting a service to do it in a way that's more 24/7 that can be taken on by a different team than the data science team. Final word here about us, just to know here you're talking to Parallel M. We are the MLOps company. We're bringing this kind of a category to the world. We focus on machine learning operationalization, technology. We're a software company. We combine expertise of machine learning, distributed computing folks, and IT operations folks. We're blending those practices together into the understanding of what we recommend to be your MLOps strategy and technology to underpin that. We're a team of just about 30. We have 5 PhDs, multiple patents pending, and our investors are the 3 largest Israeli venture capitals out of Israel. So with that, I see we're right on time. Open to questions if anyone has any. Happy to discuss those.
Thanks, Sivan. Really great presentation from the vantage point of broader industry. I will say that one of the most serious concerns that companies have in their continued investment in machine learning is exactly what Sivan addressed today. And even at our last event in December, MIT Sloan Management Review conducted a global study of 3,000 executives around the world talking about the challenges and the adoption rate. And 85% of global 2,000 companies have indicated AI and machine learning is a strategic imperative, yet only 5% have implemented anything significant. And I think the reason being is exactly what Sivan stated. So really excited about hearing his presentation. But we have some questions for you, Sivan. So let me just get right into it. What is the right time to consider, an MLOps strategy from your point of view?
Cool, thanks. Yeah, so there's two. There are 2 right times and there's a wrong time. One approach should be, most cases that we see is when people are actually realizing they actually have a problem. And that is when they, exactly as I mentioned before, you kind of manage to deploy your first 3 or 4 actual use cases in production, show the company that actually the 3 years of work on the machine learning side can actually yield or are actually ready to yield business results. At that point in time, the business is turning to you and saying, okay, now we want 100 of these by the end of the year. And by definition, you cannot get to 100 the way you got to 4. Now, we're getting customers coming to us when we do our presentations and events, et cetera, and they come and they say, wow, we couldn't even define our problem. We didn't even know how to Google the problem because these terms don't exist yet. But with the very first slide, if you remember the spoiler slide I had in the beginning, you guys managed to define the exact problem we're facing or we are about to face. So they thank us for that, and then we kind of go down our trail. So the notion is when you realize that there's a problem, before engineers start saying, oh, this is a cool problem, why don't we hack this and hack that, and maybe hard code somewhere here, and maybe take on a completely new engineering project of building a management system, I think it's a moment to step back and say, hey, hang on. If I like a bank, an example, is it the bank's core IP to go and build a complete management system solution for a scalable platform. No, the bank's IP is around machine learning models for the bank services and the unique data the bank actually has, and not build a management system that can be actually bought off the shelf and take a lot of that burden off of the team and leverage the precious resources on things that are important. So that's kind of one. The other is typically people who have experience, where we meet architects that are actually looking forward and understand that before they're hitting a problem, they should talk to somebody in order to lay down the right foundation, so they can already start upon a foundation, that an MLOps strategy and foundation, before they hit a wall and then have to scramble and look for something, because the business demands are going to only get higher, most likely exponentially, over the next 12 to 18 months. So it's better to get ahead of yourself and build something in advance. I think the less desired third option is, once you've already hard coded multiple services and you're so deep into it. We meet companies that are telling us, oh, where were you 3 years ago? 3 years ago, we were in dire need for this. We ended up having to build it because there was nobody in the market providing an MLOps solution. And now it's so hard coded into our system that it's actually too late. And they're paying that technical debt every single month, because they have to essentially run a whole company like ours in parallel to whatever they're building themselves, because it's very difficult to build a complex management solution for machine learning production. Hope that answers the question.
Yeah, thanks. Again, if anybody has any questions, please type them into the chat box on the screen. We've got a few more coming in, time for a couple more. How would you say that this is different than the DevOps practice that a company has in place now?
Yeah, so it's a good question. We get asked that a lot. I mean, we use the MLOps analogy, and people ask us, why is it really different? Why can't I just have my DevOps people also take on machine learning? Because at the end of the day, it's Python code, and code is code, and so be it. Well, the main issue here is that it's very, very different to manage an ML service than actual software service. A software service is, at the end of the day, deterministic. You're supposed to press a button and something's supposed to happen. And if it doesn't happen, or it doesn't happen within a given time, then you know it didn't happen and there's a problem. In the case of machine learning, the dependency and very, very high sensitivity to the quality and availability of the data, to connectivity, to the fact that it's actually non-deterministic. It's actually predicting something. Now, when you're predicting something, it's hard to say whether you're right or wrong. By the way, it may be predicting something which is actually wrong, which appears to be right, but it's actually wrong. So, and you cannot really say, because it's actually doing the right thing from a machine learning standpoint. The knowledge of how to get under that, the second derivative, meaning looking at the qualitative dimensions of the outputs of the machine learning, is practically, we believe, the only way to be able to understand whether that quality is actually happening within what it's supposed to and what's not. And all those things are just today are non-existent in DevOps solutions and practices. People in DevOps don't even understand most often what it means, all those notions I just talked about. This on top of the fact that there's training pipelines and inference pipelines, and when those actually talk to each other and how, all these together just mean that existing DevOps solutions are just not relevant at this point to this. So I do see MLOps as adjacent practice to DevOps, maybe a new class of DevOps, but definitely not existing DevOps solutions or people.
Thanks, Sivan. Last question. Who do you find is your primary user in a company? Is it particularly in operations or data science, management? How do you go in and coordinate with the different groups at a company, and who's the primary user?
Yeah, it's a good question, because, and here's the thing, right? What we talked about today is it's a brand new, paradigm. So the buyer and the user are not necessarily well defined yet. Here's the case we see, a couple of times every day. We usually come in and talk to the head of data science team, a person who usually has very sore eyes and is very tired of 50% of what he's doing, he or she, because that 50% is getting dragged into production issues that he or she are not interested in, not trained in, and frankly cannot help a lot. Nonetheless, they get dragged into it day in, day out, and frankly, they get very frustrated from the job. And if you talk to data scientists, the number one cause that we find that data scientists are leaving their job, and we all know how hard it is to attract and retain a data scientist. The number one reason is because the work that they're doing is not actually getting deployed, and the number two is that they're getting dragged into things that they're not really supposed to be doing, because they want to, they were hired to build models to solve a business problem. That's what they like to do. They do not want to deal with production issues. Now, to the question, most often we come in through the data scientist or head of the data science organization, at which point they realize that there can and should be a parallel adjacent team, an MLOps team that should be owning this. And then we, together with them, we start pushing it through the company. The other way is through the chief architect, or if there's some kind of business evangelist that is seeking, and is under the gun to deliver machine learning services as a strategic priority for the company. These would be the three angles that we would come in. At the end of the day, we believe there should be an MLOps person. I think that's a 2019, 2020 thing. And right now, it's the emergence of it. In most cases, still machine learning teams still own machine learning in production.
That's great. Thanks, Sivan. Really appreciate it. And thank you again and Parallel M for hosting today's webinar. I'd like to thank all of our attendees for participating as well. So this concludes our webinar for today. If you have any questions, please email us at info@aitrends.com. Thank you.